In this video, I want to talk about how to solve a polynomial inequality. So polynomial inequalities like this one can look pretty intimidating, but if you break it down with all that we know about polynomials, it shouldn't be too difficult. So the first thing is that, as with any polynomial, we know a lot more about what happens when it's equal to 0 than anything else. So the first thing is set it equal to 0. So let's move that 4 over to the other side. So I'm going to subtract 4 from both sides. So it's going to be 3x cubed plus x squared minus 12x minus 4. And that is greater than or equal to 0. Okay, my next step is I want to get a picture of what this polynomial looks like. And I like to think about polynomials a lot more when they're in their factored form. So I'm going to go ahead and try to factor it. So I'm going to try to factor this by grouping because it kind of looks like that might work. So I would take x squared out of the first two terms, and that would give me 3x plus 1. And then here I'm going to take out a minus 4, and that would give me 3x plus 1. And that's greater than or equal to 0. So then when I put this together, remember I'm undoing the distributive property here, so I'll get x squared minus 4 times 3x plus 1 is greater than or equal to 0. And then I can factor this into x plus 2 times x minus 2 times 3x plus 1 is greater than or equal to 0. And now I want to take a pause and think about what this function looks like. So there's a function, f of x equals x plus 2 times x minus 2 times 3x plus 1. I want to think about what this function looks like. So this function is also equal to this, right? It's also equal to this one. So it's a third degree polynomial, which means it makes the shape kind of like that, right? And it has zeros at what? So what are its zeros? So it has a 0 at -2, +2, and this would give me 3x minus 1 or plus 1 is equal to 0. If we subtract 1 from both sides, we get 3x equals -1. So x equals -1/3. Okay? So we have zeros at -2. So this is -2. This is -1/3. And this is +2. Okay, so that's where it equals 0. And remember, I knew that it started down, up, or started from low and goes to high because it's a positive leading coefficient. So I know it looks something like this, right? Well, my polynomial, or my inequality, asks me where is it greater than or equal to 0? Well, I can just take a look at this graph, right? So it is, here it's negative, right? Here it's positive, here it's negative, and here it's positive. So where is it greater than or equal to 0? Well, it's greater than or equal to 0 from -2 all the way up through -1/3, and then from 2 to infinity. So that's where it's greater than or equal to 0. So I would say for my answer, -2 to -1/3, and then also from 2 to infinity. And I'm using closed brackets here because it's greater than or equal to 0. If it was just greater than, I would just use open brackets. So that's how you solve a polynomial inequality. If you're not sure what the picture looks like, you can always test points in each region. So you could test what is f of x when x is 3, what is it when x is 0, what is it when x is -1, and what is it when x is -3. But if you can imagine the picture in your head and draw this little graph, you'll be able to do it without testing a whole bunch of points, which is kind of annoying. And that's how you solve a polynomial inequality.